In 2015, in the quiet industrial center of Waukesha, Wisconsin, General Electric announced it was shutting down a 109-year-old engine plant and moving production across the border to Canada. The factory had been casting and machining heavy iron since 1906. It built the blocks that pulled Liberty trucks through the mud of the First World War. It had standardized the entire American fuel industry. But by the 21st century, the fiercely independent engine builder had been absorbed into a global spreadsheet, reduced to a single line item in a corporate energy portfolio. Generations of Midwestern machinists faced the end of a familiar trade. A factory town prepared to lose the massive V12s and inline sixes that gave it its identity. The paradox was that the engines themselves had not failed. They were still running deep in American hospital basements, keeping the lights on during blackouts and pounding away relentlessly in Texas oilfields. The iron was virtually indestructible. The corporate system around it was not. But the real story of Waukesha is not only the story of a threatened factory, it is the story of the heavy, stationary engines America only notices when the power fails. Every week we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like and what happened when the market moved on. Subscribe if that history matters to you. The story of Waukesha begins not with a corporate spreadsheet, but with a specific place in the dirt roads of the American Midwest in 1906. In the first decade of the 20th century, America was not yet paved. The highway system did not exist. The roads that connected Midwestern factory towns, remote agricultural communities, and growing coastal cities were mostly dirt, which turned into deep, impassable mud for a third of the year. At the same time, the internal combustion engine, a machine that burns fuel inside its cylinders to create power, was still largely a novelty. Most early automotive engines were fragile. They were built to move lightweight wooden carriages over cobblestones or dry city streets. They were not designed for heavy labor. On the farms, heavy work was still done by horses, mules, or massive steam traction engines, which were powerful but dangerously heavy, prone to fires, and required a crew just to keep them fueled with wood or coal. It was in this gap between the fragile early automobile and the cumbersome steam engine that the Waukesha Motor Company was founded in 1906. Harry Horning and Fred Ahrens, working out of a small machine shop in Waukesha, Wisconsin, looked at the American landscape and saw a specific mechanical problem. They did not want to build a luxury car for city driving. They wanted to build a workhorse, an engine block that could survive the brutal, unforgiving conditions of American agricultural and industrial labor. Their first successful design, known as the Type A, was a rugged four-cylinder engine. A four-cylinder engine, a design where four pistons travel up and down in a single cast-iron block, offered a balance of smooth power delivery and mechanical simplicity. But Horning and Ahrens over-engineered it. They gave it massive bearings, a heavily ribbed block for strength, and an oversized cooling system. A cooling system, the network of water jackets, a water pump, and a radiator that circulates fluid to pull heat away from the cylinders, was critical because early trucks and tractors spent hours lugging at low speeds under maximum load, a condition that would boil the water out of a standard car engine in minutes. Waukesha positioned itself not as a vehicle manufacturer, but as an independent engine builder. This was a unique business model. They had to convince farm equipment manufacturers, truck builders, and industrial companies to buy their iron rather than casting their own. The strategy worked because the American commercial truck market was just beginning to emerge. Early motor trucks rode on solid rubber tires that transferred every violent shock of the rutted dirt roads directly into the chassis and the engine block. A fragile engine would literally shake itself apart. Waukesha built engines that didn't just survive the vibration, they delivered massive torque. Torque, the twisting force produced by the engine, often felt as raw pulling strength, was far more important to a truck driver stuck in a muddy rut than high-speed horsepower. By the 1910s, Waukesha was supplying engines to dozens of independent truck and tractor brands across the Midwest. The factory floor in Wisconsin expanded. It became a symphony of Midwestern manufacturing. The intense heat of the foundry, the smell of sand casting, and the heavy thud of machining lines cutting iron. But the true test of Waukesha's durability arrived in 1917 as the United States entered the First World War. The U.S. military faced a massive logistical nightmare. They were buying trucks from dozens of different manufacturers to send to the muddy trenches of Europe. Every brand used a different engine, which meant a mechanic in the field had to stock thousands of different incompatible parts. To solve this, the government ordered the creation of a standardized military vehicle, the Class B standardized military truck, better known as the Liberty truck. The military demanded a heavy-duty, standardized engine. Harry Horning of Waukesha was tapped as one of the chief engineers for the project. The result was a massive 424 cubic inch four-cylinder engine. Displacement, the total volume swept by the pistons inside the cylinders, was a direct indicator of the engine's capacity for work, and 424 cubic inches meant this engine was built to pull heavy artillery and supply wagons through deep European mud without stalling. Because the design was standardized, multiple companies built the engine. But Waukesha was a primary contractor. They churned out thousands of these heavy blocks. The Liberty truck proved that a standardized engine, backed by a universal service network, the system of interchangeable parts, service manuals, and trained mechanics that keeps a machine running in the field, could change the outcome of a war. When the war ended, Waukesha returned to a booming civilian market. Returning soldiers had driven trucks powered by Waukesha designs, and they trusted the iron. The company's engines found their way into construction equipment, cranes, road pavers, and a new generation of agricultural tractors that were rapidly displacing the old steam engines on the Great Plains. But as the 1920s approached, Harry Horning noticed a new critical problem. Waukesha could cast the strongest engine block in the world, but it was being destroyed from the inside by unpredictable American gasoline. Fuel quality varied wildly from town to town. An engine that ran perfectly in Wisconsin might violently knock and destroy its own pistons when fueled up in Ohio. Horning realized that as they increased engine compression, the squeezing of the fuel and air mixture inside the cylinder before a spark ignites it, which is necessary to make more power, the inconsistent fuel would detonate prematurely, shattering the engine's internal components. To keep their independent engine empire growing, Waukesha couldn't just build the machine. They had to figure out how to measure and control the invisible chemistry of the fuel it burned. The block had proven it could pull a truck through the mud. Now it had to prove it could define the fuel that powered the nation. By the late 1920s, the American internal combustion engine was facing a hard physical limit. As truck manufacturers and automotive engineers tried to extract more horsepower and better fuel economy, they raised compression ratios. But the gasoline refined in America at the time was entirely unpredictable. A truck driver might buy fuel in one town that ran perfectly and fill up in the next town with fuel that violently detonated inside the cylinders before the spark plug fired. This was called engine knock, and it could shatter a cast iron piston in a matter of hours. To solve this, the Society of Automotive Engineers and the American Petroleum Institute formed the Cooperative Fuel Research Committee in 1928. They needed a standardized machine to test fuel quality. Out of all the engine builders in America, they chose the Waukesha Motor Company to build it. The result was the Waukesha CFR engine, perhaps the most important, least visible internal combustion engine ever built in the United States. The CFR was a single-cylinder engine, but it possessed a unique mechanical ability: variable compression. Variable compression, a mechanical system where the heavy cast iron cylinder head could be physically raised or lowered by a hand crank while the machine was actively running, allowed a technician to change how tightly the fuel and air mixture was squeezed. In a refinery laboratory, a technician would start the CFR engine, feed it a sample of gasoline, and slowly lower the cylinder head to increase the pressure. The moment the engine began to knock, the technician checked a dial. That measurement established the fuel's anti-knock rating. It became the definitive standard for what the world now knows as the octane rating. Suddenly, Waukesha was no longer just an independent engine builder in Wisconsin. They held an absolute monopoly on the physical law of American fuel. Every major petroleum company, Standard Oil, Texaco, Gulf, and Sinclair, had to purchase a Waukesha CFR engine. Every drop of gasoline sold at an American pump, and every gallon of high-octane aviation fuel that would later power American bombers in the Second World War was calibrated against a piece of Wisconsin iron. But while Waukesha was defining the fuel that powered the nation, the ground under their original business model was beginning to shift. Throughout the 1930s, the American truck and agricultural equipment markets began to consolidate. Large manufacturers like International Harvester and Mack Trucks realized that buying engines from an independent supplier like Waukesha cut into their profits. More importantly, it meant they could not control the lucrative aftermarket for replacement parts. These manufacturers began shifting to captive engines, power plants designed and cast in-house by the vehicle manufacturer themselves. If a fleet owner bought an international truck, it now came with an international engine. This locked the truck fleets and farmers into a single, closed service network. Slowly, the independent engine builder was being squeezed off the American highway. A fleet manager could still trust a Waukesha block, but he could no longer order one under the hood of his preferred heavy truck. Waukesha realized that if they relied purely on the automotive and highway freight markets, they would eventually be starved of orders. They needed a market that demanded absolute mechanical endurance, but did not care about the brand name stamped on the hood of a vehicle. They found it in the very substance they had helped standardize: petroleum. As the Texas and Oklahoma oil booms accelerated, energy companies needed a way to pull crude oil out of the earth and push it through thousands of miles of new pipelines. The oil fields were brutal environments. An engine sitting in the West Texas sun had to run 24 hours a day, 7 days a week, for months at a time without a mechanic touching it. Furthermore, hauling liquid diesel or gasoline out to a remote pump jack was expensive and dangerous. But oil wells produced something else: raw, unrefined natural gas. Waukesha engineers executed a brilliant pivot. They took their massive, heavily reinforced industrial engine blocks and modified them to become natural gas engines. A natural gas engine, an internal combustion engine equipped with specialized carburetors, hardened valves, and adjusted spark timing to burn dry, hot gaseous fuel rather than liquid gasoline, could be plumbed directly into the wellhead. The engine could literally run on the byproduct of the hole it was pumping. This shifted Waukesha permanently into the world of the stationary engine. A stationary engine, a machine designed not to propel a vehicle, but to be bolted to a concrete pad to continuously drive industrial equipment like pumps, generators, and compressors, required a completely different engineering philosophy. Weight was no longer a penalty, it was an advantage, as heavy cast iron absorbed vibration and dissipated heat. Waukesha built massive oil pans that held dozens of gallons of lubricant so the engines could run unattended. They built low-stress valve trains that would not wear out even after 10,000 hours of continuous operation. In the oil patches of the American Southwest, the rhythmic low RPM pounding of a Waukesha natural gas engine became the heartbeat of the petroleum supply chain. They had successfully escaped the trap of the captive truck market. By shifting their focus away from vehicles and toward the unseen infrastructure of the country, Waukesha cemented its survival. Waukesha had lost the highway, but they had found something more permanent: the American basement, the oil field, and the grid. And by the middle of the 20th century, the Waukesha Motor Company was no longer just a successful Midwestern machine shop. It had become the silent, heavy-duty, mechanical backbone of American infrastructure. While the automakers in Detroit were capturing the public's imagination with high-revving V8s for the new interstate highway system, Waukesha was building a completely different kind of power. They were building the iron that operated in the shadows. The Waukesha factory in Wisconsin had expanded into a sprawling complex of foundries, machining lines, and assembly bays. It was a place defined by intense heat, the smell of industrial cutting fluid, and generations of skilled machinists who spent their entire careers cutting exact tolerances into massive blocks of cast iron. At its peak, the scale of Waukesha's engineering was staggering. They were no longer building four-cylinder tractor engines. They were casting machines like the legendary Waukesha VLR. The VLR was a V12, a 12-cylinder engine with cylinders arranged in two banks in a V shape. But automotive terms do not accurately describe its size. The VLR displaced an incredible 5 788 cubic inches, To put that displacement into perspective, a standard American muscle car V8 of the era might displace 350 cubic inches. The Waukesha VLR was roughly 16 times that size. It was a machine so massive it had to be transported on reinforced rail cars and lifted by heavy industrial cranes. When configured as a natural gas engine for the oil fields, or a diesel engine, an engine that ignites fuel by compressing air until it becomes hot enough to burn, the VLR could produce over 1,000 continuous horsepower, running for months at a time without ever being shut down. These massive blocks found their true calling as the ultimate American generator engine. A generator engine, an engine strictly used to turn a heavy alternator and produce electricity, operates under a unique kind of stress. It does not accelerate or decelerate. It must snap to a specific RPM immediately upon startup, lock onto that speed, and hold it perfectly steady, regardless of the electrical load being demanded. If the engine speed fluctuates, the electrical frequency fluctuates, which can destroy the equipment it is powering. Waukesha dominated this high-stakes environment. This created one of the most powerful, yet entirely hidden, cultural moments in American engine history. Deep in the sub-basement of an American hospital, housed in a concrete generator room completely isolated from the patients above, sat a Waukesha V12. For months, it would sit completely silent, kept warm by block heaters, waiting. Then a severe winter storm or a hurricane would strike. The municipal power grid would fail. The hospital would plunge into darkness. In that terrifying silence, automatic transfer switches would close. Down in the basement, high-torque starter motors would engage. Within 10 seconds, the massive Waukesha engine would ignite, settling into a deafening rhythmic roar. The lights in the operating rooms would flicker and blaze back to life. The life support systems would stabilize. The entire building would vibrate slightly from the sheer mechanical violence of the iron working in the basement. In an America where an engine could decide whether a hospital survived a storm, a municipal water system kept flowing, a telecommunications network stayed online, or a pipeline moved millions of gallons of crude oil, power was not an abstraction. It was iron, natural gas, diesel fuel, heat, sound, and absolute mechanical trust. Waukesha had achieved a strange kind of mechanical greatness. They were the most important engine builder that the average American consumer would never see. Beyond the hospital basements and municipal water plants, Waukesha found its most lucrative and grueling application in the post-war American energy boom. After the Second World War, the United States began a massive transition away from coal and toward natural gas for home heating and industrial power. But the natural gas was trapped deep beneath the deserts of Texas, Oklahoma, and New Mexico, while the cities that needed it were in the cold industrial Midwest and the crowded Northeast. To move that invisible energy, the country built tens of thousands of miles of high-pressure interstate pipelines. To push gas through a steel pipe for 1,000 miles, it requires immense, continuous pressure. This pressure was provided by compressor stations strategically placed along the pipeline routes. Inside those remote corrugated steel buildings sat the ultimate expression of Waukesha's engineering, the heavy-duty compressor engine. A compressor engine, an industrial motor specifically designed to drive a heavy mechanical pump, increasing the pressure of a gas so it can travel across vast distances, lived a life of pure mechanical torture. These engines were bolted to massive concrete pads in the middle of nowhere. There were no drivers to monitor the gauges. There were no mechanics standing by. They ran 24 hours a day, 7 days a week, often fueled by the very raw, unrefined natural gas they were helping to compress. In this environment, an automotive V8 from Detroit would have disintegrated in a matter of days. A Waukesha was expected to run for 40,000 hours before requiring a major overhaul. An overhaul, a major service process where an engine is completely taken apart, its internal tolerances measured, and its bearings, rings, and seals replaced to restore it to factory operating standards, was an expensive undertaking, so oilfield operators demanded iron that simply refused to quit. Waukesha delivered by over-engineering every internal component. They used forged steel crankshafts that weighed more than an entire compact car. They designed massive oiling systems that constantly bathed the bearings in hundreds of quarts of heavy lubricant. By the 1950s and 1960s, the rhythmic, low RPM thud of a Waukesha inline-six or V12 was the defining sound of the American oil patch. The company had built a sprawling, highly specialized service network across the American Southwest. A service network, the system of authorized dealers, parts suppliers, heavy-duty mechanics, and detailed manuals that keeps a machine running in the field, was just as important as the iron itself. In dusty oil towns from Midland, Texas, to Bakersfield, California, independent distributors kept warehouses full of Waukesha pistons, gaskets, and cylinder heads, ensuring that if a pipeline engine ever faltered, it could be rebuilt on site before the pressure dropped. Back in Wisconsin, the factory town of Waukesha was thriving. The Waukesha Motor Company had grown into a massive industrial complex. It was a self-contained empire of American manufacturing. The foundries poured hundreds of tons of molten iron every week. Machinists operated heavy lathes and boring machines, cutting precise cylinder walls into iron blocks that were so heavy they had to be moved by overhead bridge cranes. This was a generational factory town. Fathers taught their sons how to read the micrometers and operate the milling machines. The workforce took immense pride in the fact that they were not building disposable consumer goods. They were building the mechanical foundation of the country. They knew that their engines were turning the irrigation pumps that kept the Great Plains green, powering the backup generators that kept East Coast hospitals lit, and driving the compressors that kept the Midwest warm in the winter. At its peak, Waukesha achieved something few independent engine builders ever managed: total market saturation without relying on the volatile passenger car or highway truck markets. They had successfully navigated the shift away from agricultural tractors and wooden spoke trucks, reinventing themselves as the undisputed kings of stationary power. They had built a machine so reliable, so perfectly suited to its industrial task, that it became practically invisible. The average American homeowner turning up their thermostat in Chicago or drinking a glass of municipal tap water in Ohio had no idea that a massive piece of Wisconsin iron was pounding away in the darkness to make it possible. But this incredible strength was entirely mechanical. It was built on the logic of thick iron, skilled labor, and independent distributors. It was not built on the logic of modern global finance. As the 1970s approached, the business of building engines in America was about to fundamentally change. The threat to Waukesha would not come from a better engine design, a stricter emissions rule, or a failure of their machinery. The threat would come from the balance sheet. In a storm, America trusted the iron from Wisconsin. But on Wall Street, iron was just another line on a spreadsheet. The collapse of the independent American engine builder did not begin with a factory shutdown. It began with a small, almost invisible crack in how American industries bought their power. By the early 1970s, the Waukesha Motor Company was still pouring iron and cutting massive cylinder blocks in Wisconsin. But the distributors out in the field, the independent shops in Texas, Oklahoma, and the Midwest that sold and serviced these engines, began to notice a shift. For decades, a hospital or a drilling company would buy a bare Waukesha engine block, and the local distributor would custom build a generator or a compressor around it. But the market was moving toward packaged power. Packaged power, a system where a manufacturer sells a completely integrated unit, including the engine, the generator, the cooling system, and the electronic controls all in one box, was faster and cheaper for a hospital or a municipality to install. Companies like Caterpillar and Cummins were leveraging their massive scale to sell these turnkey solutions directly, squeezing out the independent engine builders and their local dealers. Waukesha found itself caught in a dangerous position. They built incredible engines, but in a consolidating American economy, selling just the bare machine was no longer enough. The cost of manufacturing heavy iron in the Midwest was rising, while the profit margins on bare engine blocks were shrinking. This pressure introduced Waukesha to a new unforgiving market force: corporate consolidation. In a financial environment where raw scale dictated survival, the independent engine maker became a target. In 1973, the fiercely independent Midwestern company was purchased by Bangor Punta. Bangor Punta was not an engine builder. It was a massive multinational conglomerate that owned everything from Smith& Wesson firearms to Piper aircraft to sailboats. To the executives in the conglomerate, the Waukesha factory was not a vital piece of American infrastructure or a proud generational trade. It was merely a line item on a spreadsheet expected to generate a specific quarterly yield. The badge on the engine remained the same. The heavy V12s still rumbled in hospital basements during storms, but the soul of the company had shifted. The men on the foundry floor in Wisconsin were no longer working for a local company that understood the physical reality of an oil pump in the Texas dirt. They were working for a holding company. That specific ownership lasted less than a year. In 1974, Bangor Punta sold Waukesha to Dresser Industries, a colossal oilfield services corporation headquartered in Dallas, Texas. On paper, the acquisition made perfect logical sense. Dresser built the pumps, compressors, and drilling rigs for the global energy industry. Waukesha built the heavy natural gas engines that powered them. But this acquisition fundamentally changed Waukesha's identity. They were no longer an independent engine empire competing on the open market. They had been reduced to a captive supplier, a subsidiary whose primary purpose was to provide sub-assemblies for Dresser's larger petroleum projects. The independent dealer network, which had spent half a century building trust with local farmers, municipalities, and wildcat drillers, suddenly found themselves subordinated to Dresser's massive corporate sales structure. Then the American engine market was hit by another force: energy shocks. The late 1970s and early 1980s saw wild volatility in global oil prices. When oil prices collapsed in the mid-1980s, the domestic petroleum industry effectively froze. Drilling rigs stopped turning, pipeline expansions were halted, and suddenly, Dresser Industries did not need as many massive natural gas compressor engines. The Waukesha factory in Wisconsin felt the immediate physical consequence of this global market shift. Production lines slowed. Layoffs hit the generational workforce. The heavy lathes and overhead cranes sat idle for longer periods. The men and women who machined the iron realized that their livelihoods were entirely dependent on the fluctuating price of a barrel of crude oil halfway across the world. Despite the corporate turbulence and the energy crashes, the iron itself remained incredibly resilient. In the late 1980s and 1990s, Waukesha engines faced a new existential threat: environmental regulation. The Environmental Protection Agency began looking closely at stationary power. The massive natural gas engines thumping away in the oil fields and municipal power plants produced significant nitrogen oxide emissions. Regulation does not simply outlaw a machine, it creates a new engineering problem. Waukesha engineers responded by developing the ATGL series, an advanced lean burn technology. A lean burn engine, a design that introduces a much higher ratio of air to fuel inside the cylinder during combustion, burns cooler and drastically reduces harmful emissions without sacrificing continuous industrial power. Waukesha successfully adapted their massive blocks to meet the new legal reality, proving that the Midwestern machinists still knew how to solve impossible physical problems. But survival through engineering came at a massive financial cost. Developing new emissions-compliant cylinder heads, advanced carburetors, and precise ignition systems required tens of millions of dollars in research and development. The cost to cast, machine, and assemble a heavy-duty industrial engine was skyrocketing, and the Dresser conglomerate was beginning to look for ways to optimize its portfolio. The factory in Wisconsin kept running. The heavy natural gas engines kept moving gas through the interstate pipelines. But the financial structures surrounding the factory were growing increasingly unstable. Waukesha had proven it could engineer its way out of an energy crash and an emissions mandate. It had not yet proven it could survive the ultimate corporate predator that was waiting in the 21st century. As the 21st century began, the Waukesha factory in Wisconsin was still operating, but the company's identity was fracturing. They were still casting massive blocks for the VHP, the Very High Power Series, and sending them out to the Texas oil fields, but the corporate ground beneath them was constantly shifting. In 2010, the illusion of Midwestern independence was permanently shattered. General Electric, one of the largest multinational conglomerates on the planet, purchased Dresser Industries. Waukesha was absorbed into GE Energy. To a machinist on the floor in Wisconsin or an independent distributor in Oklahoma, this was a massive cultural shock. General Electric was a company famous for building massive jet engines and high-speed gas turbines. A gas turbine, an engine that uses spinning turbine stages and high-speed gas flow to produce power, represents the exact opposite engineering philosophy of a heavy reciprocating iron block. Turbines are lightweight, high-tech, and incredibly expensive. Waukesha built heavy, slow, cast-iron workhorses. Inside the massive GE portfolio, the Waukesha engine was recategorized. It was no longer the proud flagship of a dedicated engine builder. It was simply a minor asset within the distributed power division. The immediate consequence was felt in the service network. For decades, if a compressor engine went down in the Permian Basin, an independent mechanic could call a local distributor, talk to a parts counterman who had memorized the Waukesha catalogs, and get a replacement cylinder head on a truck the same day. But under conglomerate ownership, service networks are often streamlined to satisfy global efficiency metrics. Legacy parts for older engines became harder to source. The vast network of independent knowledge was slowly replaced by automated corporate supply chains and digital service portals. The engine still required oil, torque, and heavy wrenches, but the system supporting it was optimized for a spreadsheet. Then came the event that finally broke the spirit of the historic Midwestern factory town. In September 2015, General Electric delivered a devastating announcement. They were going to shut down the historic Waukesha manufacturing facility and move engine production to a new plant in Welland, Ontario, Canada. For the generational workforce in Wisconsin, the news was incomprehensible. The factory had been running continuously since 1906. It had survived the Great Depression, 2 world wars, the collapse of the independent truck market, and the oil bust of the 1980s. The engines they were building were still profitable. They were still demanded by the oil fields and municipal power grids. But the closure had absolutely nothing to do with the quality of the iron. It was entirely about global corporate leverage. General Electric was embroiled in a political dispute in Washington over the reauthorization of the United States Export-Import Bank, a federal agency that provided financing for foreign buyers of American goods. When Congress temporarily allowed the bank's charter to expire, GE argued they could no longer secure the financing needed to sell engines overseas. Their solution was to instantly uproot a 109-year-old American factory and move it to Canada, where the Canadian Export Credit Agency would provide the necessary financial backing. A century of American engine history was suddenly expendable over a trade financing dispute. The paradox was staggering. The Waukesha natural gas engine, a machine specifically designed to provide absolute, unshakable stability when the world around it failed, could not stabilize its own factory against the forces of global finance. Ultimately, the political gridlock in Washington was resolved. The Export-Import Bank was reauthorized, and GE quietly reversed its decision. The Waukesha plant was spared from the wrecking ball. The heavy lathes kept turning, and the foundries kept pouring iron in Wisconsin. But the psychological damage was permanent. The event proved that the Midwestern engine builder was no longer the master of its own fate. The workforce realized that 100 years of mechanical excellence could be erased in a single afternoon by a corporate boardroom located 1,000 miles away. In 2018, the corporate carousel turned one last time. General Electric decided it wanted to focus exclusively on aviation and massive power turbines. They no longer wanted to be in the business of heavy reciprocating engines. GE sold Waukesha, along with its Austrian sister brand Jenbacher, to Advent International, a global private equity firm. The 2 engine lines were merged into a new corporate entity called INEO. The Waukesha badge was saved, but the independent Midwestern engine empire was gone. The engine still ran. The block was still cast. The name stayed on the valve cover. The natural gas kept pumping, but the old company was dead. The independent dealer network was swallowed. The factory became a portfolio asset. The old iron became corporate leverage. The badge remained. The world it powered was gone. Today, the Waukesha factory in Wisconsin is still operating. Under the ownership of INEO, the massive foundry still pours iron, and the machining lines still cut cylinder walls for advanced, highly efficient, emissions-compliant natural gas engines. The badge survived the corporate turbulence of the 21st century. But the original Waukesha Motor Company, the fiercely independent Midwestern engine empire that built blocks for World War I Liberty trucks and convinced thousands of American farmers, fleet owners, and wildcat drillers to trust their iron, is gone. The factory is now a specialized node in a global energy portfolio. The independent dealer network that once blanketed the American Southwest has been entirely absorbed, streamlined, and digitized by corporate efficiency models. Yet the true legacy of Waukesha does not live in modern corporate press releases. It lives in the incredible, stubborn survival of the heavy iron they left behind. Old American engines rarely vanish cleanly, but Waukesha engines possess an afterlife unlike any other machine in the country. Because they were built for the unseen infrastructure of America, they were never subjected to the whims of consumer automotive styling. A truck from 1950 looks entirely obsolete on a modern interstate. A stationary engine, a massive cast iron block bolted to a concrete pad to turn a pump or a generator, does not care about the calendar. It only cares about oil pressure, natural gas, and torque. Because of this, thousands of vintage Waukesha engines are still working today. Deep in the Texas and Oklahoma oil fields, independent rebuild shops still warehouse vintage Waukesha parts. Mechanics who learned the trade from their fathers still overhaul the heavy inline sixes and massive V12s that Dresser Industries tried to sideline decades ago. In municipal water plants across the Midwest, 40-year-old Waukesha backup generators are still kept warm by block heaters, tested every month, and trusted to keep entire cities from going dry when the modern electrical grid fails. Even more remarkably, the Waukesha CFR engine, the variable compression testing machine invented in 1928 to measure fuel quality, is still the absolute legally required standard for the global petroleum industry. If you buy a gallon of high-octane gasoline anywhere in the United States today, that fuel's rating was certified by a mechanical descendant of the exact same single-cylinder machine designed in Wisconsin nearly a century ago. The automotive industry moved on to hybrid systems, electric vehicles, and software-controlled fuel injection. But the chemical law of American fuel is still enforced by a piece of heavy Waukesha iron. This preservation is not nostalgia. An old Waukesha engine rumbling in a remote compressor station is a physical argument about a time when American infrastructure was built on mechanical mass rather than microprocessors. It is a reminder of an era when reliability meant thick cast iron blocks, hundreds of quarts of heavy oil, low RPMs, and a machine that could be kept alive with wrenches, replacement parts, and a local service manual, rather than a sealed unit that requires a factory laptop to diagnose. Today, if you walk through a vintage engine show in rural America, you will occasionally find an old Waukesha four-cylinder block pulled from an early agricultural tractor, carefully restored by a collector who understands what it took to pull heavy plows through the mud before the highway system was paved. You will find oil-stained Waukesha service manuals in the toolboxes of retired mechanics, the pages permanently marked by the greasy fingerprints of men who kept the country's hospitals lit during severe winter storms. You will find massive rusted cylinder heads sitting in the weeds behind salvage yards in the Permian Basin, stripped for parts to keep another engine running out in the dirt. These surviving objects prove that America did not stop needing power. It simply stopped needing to know where that power came from. The independent engine builders who laid the foundation for the modern grid were slowly squeezed out by captive manufacturing, global supply chains, and multinational conglomerates. The country learned to flip a switch and expect the lights to come on, completely forgetting the Midwestern machinists who built the physical machinery to make it happen. The sound survived longer than the business model. The heavy, rhythmic thud of a naturally aspirated gas engine is still the heartbeat of the American energy supply chain, even if the independent company that engineered it has long since been swallowed. Somewhere in the American Southwest, at the end of a long, unmarked dirt road miles from the nearest interstate highway, an old Waukesha Inline 6 sits inside a corrugated steel shed on a cracked concrete pad. Its heavy cast iron block is faded, coated in fine dust and decades of thick grease. There are no mechanics standing nearby. There is no modern corporate logo on the chain link fence, but the massive steel flywheel is still turning, pounding away relentlessly in the brutal summer heat, quietly keeping the pressure up in a pipeline that the rest of the country has already forgotten. See you in the next one.